Hello guys, in this video I'm going to show you how to solve merge intervals problem. So given a list of intervals, merge all the overlapping intervals to produce a list that has only mutually exclusive intervals. So let's look at the visualizations. So here is our time frame. So each interval is a small time frame that has start and end, start time and end time. Right? So for this one, it started at 1 and end at 4. This one started 3 and end at 6. This one started 7 and end at 9, and so on. Right? So given the intervals, we want to merge the intervals that collapse. For example, in this example, these two are collapsed. Right? You can see here is the overlapping part. So for these overlapping intervals, we wanna merge them together. So 1 to 4, 3 to 6. We merge them together to produce a merge interval, which is 1 to 6. Okay? Same here, 7 to 9 and 8 to 10. So as you can see, they collapse from 8 to 9, right? So these two intervals can be merged into 7 to 10. Right? So for this kind of problem, it falls into merge interval technique problems. So for this kind of problem, we want to the first thing to do is to sort all these intervals, because our intervals, let's say for each interval we have start and end, right? Start run and run. We have so many lot of intervals inside. Start 2 and 2, but these are unsorted. It has no order, so the first thing we want to do is to sort these intervals by the start time. So let's see the test. Let's take a look at test. So this one, for example, let's cut it out. In order to sort in JavaScript, but here we are gonna sort. We're not sorting number, but sorting object based on the first element of each array, right? Each array is an interval. So let's see how so for example, store it in a variable, right? So we expect the result should be 2 4 with the first one, then 5 9 second, and 6 7. We sort by the um, by the open time, right? So in order to sort, we use the built-in function sort. So we have let's say x and y, because we sort by the open time. So we sort by the open time in ascending order. So it's we extract x is an interval, y is an interval. We access the open time of these two. So by doing this, we're gonna have the sorted versions, right? 2, 5, 6, right? So why we want to sort by the start time? The reason we want to have sorted intervals by start time is that we want to traverse. We want to look every interval from the, let's say, from the one that happens earliest, right? So here the order after sorted. So by sorting this by start time, we can look for every interval. So as you can see, we always have two in the sorted array, two we always have two intervals with the highest chance of collapsing is put together in the sorted array, right? So by sorting them, we have all the collapsing, all the all the overlapping intervals are put next to each other, right? So that's the reason why we sort it by. So after sort the intervals by the open time, we want to iterate to every interval. Right, we start with this one first. We probably want to start with the second intervals, right? Because the first one, there's no chance of because for the first one we couldn't know, we don't have anything to compare to know that it overlaps with something else. So we start from the second one, we check probably for each interval we want to keep a previous interval so that we can compare these two, right? So we keep interval is the first one. We start iterate from the second one. Oh, as you can see, there's possible cases is that the current interval can be overlaps with previous interval. For that case, we probably want to merge them together. So probably we want to update after merging these together, we probably want to update the previous. So this can be the previous of the next interval, right? So here is the previous. After the second iteration, we move to this one, right? Here's another case, which is, as you can see, the previous doesn't overlap with the current, right? So it means okay, we done with the previous one. There are no chances of anything that come later in our sorted array will overlap with the two with the previous interval. So for that case, we want to push the previous to the result list. So that's basically how the algorithm works. Let's start coding. We wanna, yeah, of course, we wanna need a result interval. We start by sorting the intervals, right? Intervals is a arrays of two numbers. Number that changes to TS. Oops. Okay. We'll sort the interval same as what we've done here. We sort the callback taking two parameter A and B. We accept A, the starting time A and starting time B. So this will, after this operation, the interval is sorted by starting time. So next thing you want to do is to store the previous, is the first one, the first interval. The first intervals in intervals 0, right? The previous. So wanna start from 1, right? From index 1 is intervals. We go all the way to the end of the interval list. So wanna store the current interval. intervals at the index I is current. So after all, we will return result. So what are the possible cases we have here? So the first scenario is, let's say, what if the previous, let's say here the previous and here the current, it has no collapse, right? So for this guy, we'll now just want to push this one to the result, because anything that come after will not collapse with this one, right? So if the start of the current, which is current at index 0, is greater than the end of the previous and right. In this way, we want to push the previous, else in the case when we have something like this, right? The start of current intervals is inside the previous interval, so it collapses. They collapse with the current interval collapses with the previous interval. Right. For that case, we want to merge these together. How can we do that? How can we merge these together? We can update the previous, right? We will update the previous with the current data, with the current interval, right? But there are two sub cases here, right? Can you guess it? The first one is either the end of the current previous can be the whole current previous can sit inside the previous interval. So, in the other case, is the end of current intervals is outside of the previous interval. So for these two cases, we have to update the previous interval, right? For this guy, we wanna just for this guy we don't have to update because the current intervals sits inside the previous intervals, so that merging these together so that we can merge it together into whatever the previous interval is, right? So this will not have any effect to the merge interval, but for this case the merge interval will be updated. The merge interval will be start of previous interval. Start of merge interval is this one, which is the start of previous interval, and end of merge interval is end of current interval, right? So we have two cases here. So if this is the case, current start time current is within the, we want to update the previous interval, right? The previous interval, what we want to update here is the end time, right? The start time will always will not change, but the end time can change. The end time is previous of 1, right? Equal to is, for these two cases can be grouped into only one logic, which is we take the whichever a larger, whichever close time is larger, which means max equal to pref and current, right? So what else we can do? We update the previous interval. So that come back here to after this slide we come back here, we inspect the next interval and compare them together. What else we're missing, I think? Right, for this guy, if it is there, they do not collapse. This guy, we push previous to the resolve. Probably here we want to update the previous as well. We push into the previous E now equal to current, right? As you can see, for this guy, let's assume that this is the previous, this is the current. Okay, now we are sure that they will not collapse. We push the previous to our resolve. Okay, and reassign the previous to the current so that for the next for the next iteration we have the previous E, this one, but not this one. So we reassign the previous. Okay. Probably we can what if in case we are the, let's say in this case we are here, right? We're here with the last, the previous this interval. We are in this case, they collapse, they overlap. So we update the previous n, right, to this one because it is larger one, right? So we come here to update and exit the loop, and the previous at that time we will store the last merge interval, but we haven't pushed it to the result yet, so probably after we exit the loop we want to push the previous to the result. Just let's test it. It's not, it fails at the first let's try to test this one. Put a debug here. Let's see. Oh, previous 6 to 7. Alright, we start from 1 all the way to the end. Iterate. Let's say see the intervals. Oh, it's not sorted. Oh, sorry. Should be 0. Right. Alright. It works now. Thank you for watching. See you in the next video.